Okay, today we're going to be looking at a 1984 Robocom robot. And that's what it looks like. I do not have the voice controller. It's a voice-activated robot that does things that you ask it to do while talking to it. And it was given to me to take apart and make sure that the innards still work. They're looking for their controller. So, let's see what's inside of this almost 30-year-old robot. First thing I noticed is it has a little bit of a battery leakage. We got white corrosion in here, which are C batteries apparently, and white corrosion pouring out of the AA batteries. Now, if I turn it on, the little red light comes on, but that's it. I don't know if that's all it's supposed to do. According to the owner, this quit working a long time ago. What I can notice by just visually looking at it is this one wheel has a flat spot right here, and this one's completely round. So somehow this got ground down. It could have been ground down from being pushed or pulled, or my hypothesis is it quit turning and this thing just kept spinning in a circle like so, which will grind down the inner wheel. So, we'll open it up. It's kind of interesting. The hands are spring-loaded, so you can, open it up and it's going to hold a tool for you. So, first thing I'm going to do is let's pop these batteries out. I haven't opened it up to look. You can see there is no break in the corrosion. Maybe part of it is these nasty batteries. Of the 4 Duracells, one of them popped. The first one right there. Oh, there's also a 9-volt in here. Alright. There's a 9-volt right there. So, there's the bad battery. I'm sure these are all flat. I know this one's definitely bad, so I'm going to throw that one away. Let's see if I can get this 9-volt out. Get some of that corrosion out. And now let's open the next side. The reason I'm using a screwdriver is these things don't open. I couldn't open with my fingers, so that's why I'm going to use a screwdriver to help pry them back. Well, yeah, both these batteries detonated itself. They're all let out their magic go juice. Oh, yeah, and they're really stuck in there. Holy smokes, they're really stuck in there. Get some of this off. There we go. It's one nasty battery gone. And 2 nasty battery gone. So, let's scrape away the acid, the dried acid. Toss that. Let's just do a quick test on the batteries. I have all the batteries here just to replace. So, but I want to test this 9-volt. The 9-volt still has 9.3 volts in it. I do have another 9-volt right here. Let's test this one. Actually, the old one has more power than the newer one. That's amazing. Oh, the battery is 0.9. That's too low. 0.9. You should be at 1.5, give or take. So these 3 batteries are technically flat. Here's a brand new one, just so you can see. 1.6. So. For testing, I'm just going to scrape off the contacts and put the batteries back in, new ones, see if it does anything, and then we're going to open it up. Then I'll take the batteries out and I'll clean out this compartment with rubbing alcohol. Rubbing alcohol is a good cleaner for corrosion from batteries, also sticky stuff like residue from stickers. This guy's antenna keeps getting caught in everything. Yeah, this is why they tell you never to store batteries, because of this acid. Most things, though, you can clean or repair. But well, we got a red light on the top and a red light in the belly. And that's probably all we're going to get without the controller. So his head's lit up and his belly's lit up. So, but let's open her up. To open this thing, it appears there's only 6 screws on the back. 1, 2, 3, 4, 5, 6. They are Phillips. They appear to be number 2s. They are. So let's move some of this stuff out of the way. The person I got it from got this as a child, and he really liked it. And he found it in storage. He says it doesn't work, so I'm assuming he has the controller. He just didn't give it to me. So, and even if I can't find anything wrong inside, we can take a look into 1984 technology of a voice-controlled robot. Which today people are like, I can do that with my Roomba or my, through an app on my phone. But this was fancy high-tech stuff, 40 years ago. You know it's old from the 80s because C batteries were really popular back then in toys. The fact that it's got A's, C's, and 9 volts, amazing. That's why it cost so much to feed toys back in the old days. Alright, looks like I have to separate the base. This part separates, but it's getting caught right here, and there are screws in the bottom. So I am going to try and unscrew these. They are also Phillips, which is also nice about older toys, is they usually ran the same screws for everything. Except my screwdriver is, the coating on the shaft is the same size as the hole, so it takes a second to get it in all the way. I'm just going to take out the back two and see if I can just separate the back. Leave the front two on. There we go. So let's take a look at the inner workings of Robocom's robot. First, the arms just swing naturally. There's no motors or servos on them. Second, it's not too terribly difficult to take apart. this sticker on the front that says voice recognition Robocom. You can see it's just a straight through sticker. I can push it back out on this side. So I'm wondering if they had a different option. We got a little white light that lights up the eyeballs. Right there. We got a circuit board and its command chip or command center with the, most likely has the blob chip inside here. The majority of the brains. But let me see if I can get this drivetrain to work. So I am going to end up taking off the front two screws so I can get access to where the axle is. There are a couple of screws that hold the housing onto the axle. So they're diagonal from each other. There goes his head. His dome has a purplish tint to it. You may not be able to see in the light. And there's his head. There's the top view where you can see the box that controls probably the voice recognition circuit. It didn't leave a lot of slack on these wires. So I'm trying to get this housing off without breaking any of the wires to any of the components. We have a full gearbox inside here. Alright, well, they did put a twist tie on here. So let's untwist it. Oh, that helps a lot. Itty bitty little guy. And lift off the housing. And there we go. We have two motors, one for each wheel, which is anticipated so we can steer. Small gearbox for each side. Looks like coming off the motor we have a total of 4 gears on each side for each independent axle. The axle goes through the center of the housing and probably in between the two motors is split so it doesn't interfere with each other. For as old as this is, I don't see any cracks in the gears. I see that the pin is loose for this gear. We'll take a look at that. I don't know, it is sticking. There might be a crack in the gear and I can't see it. Yeah, it sticks right there. There's got to be a small fracture. That might be why I was spinning in circles, is because I was caught on that and it was grinding down the rubber drive wheel. So we got some x-ray specs on, or actually just magnifying glasses. And I want to... Yep. The gear coming off the motor is actually split. And this is the side that's got the flat spot. So now let me check the other side. I do wish I had the controller because it'd be kind of cool to see this thing work. This one is also split. Same small gear. It's a 1, 2, 3, 8-tooth gear. I'll try and bring it up to the camera without breaking off any of these wires. And get a closer look at the inner workings of a 1984 Robocom. So there's your two motors with a capacitor and a resistor on each. And then if you look right here, this is the drive gear that comes off of the motor. And on both sides, this drive gear is cracked. So I'm going to figure out how to get these replaced, because these pins, if you can see, they have flat heads. They're pressed in, and this motor also has a flat head. Normally the shaft is smooth, and I wonder if they did that so it didn't walk off under motion. So they peened the end of the shaft over, which is going to make it a slightly more difficult repair. So, same as the housing, there's two screws that are diagonal from each other. Oh, nope, they're not diagonal. They're just straight across from each other. Alright, I can't get that one out at the moment. So here's the drive mechanism. Separated, and it's one solid axle, and what they did is they used the wheels to slide on the axle. So the axle is acting as a solid piece, and then the gears with the separate wheels is acting as basically like a separate differential or independent drive. And the inside of the gear fits into, the nose of the gear fits into the axle. The inside of the axle's got very small teeth. A very small tooth. It has a single tooth. That single tooth just catches one gear on the nose and prevents it from slipping. That's rather interesting. So the axle just slides all the way through. And that's how you get your independent drive. So you can just do this, or together, and that's how you get your independent drive. And this is the one that was spinning, and this is the one that apparently was spun on, because there's the flat spot. So now, how do we get this apart? It's also a very unique set of motors. It has springs in them. Not sure what those are for. There they are. So you're going to get one of these gears that come off. There we go. Okay, it's not peened. It just looks peened. There's a dent in the middle. There's the first 8-tooth that's broken. And there's the second one. So they actually come off pretty easy. You probably don't even have to disassemble all of this. You can probably leave this attached just to get those two off if they're broken. But to make it easier to see in the camera, that's why I took them off, to see how this is assembled with the two motors facing opposite directions and then two of the exact same drives. So we need to find two 8-tooth gears that appear to have a 1.5 millimeter shaft. If you found gears of the same size with different teeth ratios, it would just change the speed at which they rotate. This is a 1, 2, 3. I could just overlap them. I think this is a 10-tooth gear. Yeah, it's a 10-tooth. That's too big. The only problem with sticking them all in a single container is it's hard to find the small guys. Thought about getting one of those like sewing kits where they puts all the little bobbins in it and using it to separate the gears. Here's a small 8-tooth. And let's see if I have another. And that's another small 8-tooth, but the shaft hole is smaller. So here's a bigger one right there. All right. One of the reasons I keep these all together like this is they all come from the same manufacturer. They're two different kits that I mixed together, or two kits I mixed together. They're the same kit, just purchased at two different times. But yeah, I really need to find a new way to organize my gears, especially these, because these are the more common used ones in most of the hobbies, like Mr. Robocom here, as well as Leakage and Department 56. Little animated houses, and even just some older toys. They use basic Chinese made gears. So now they're a lot harder to slide on when they're not cracked, but when you do slide it on, you got to make sure that your teeth line up and you don't force it and snap the teeth of the gear next to it. So you want to make sure that your teeth mesh like so, and it's nice and smooth, no binding. So, and this is what I'm talking about on the size of the hole. I'll see if the camera will show it very well. You can see that the new gear is smaller than the old gear. So I got two 1 millimeter shafts instead of a 1.5. So I'm going to have to dump this out and see if I have another large one. If not, I'll have to bore one of those out to the bigger size. I didn't notice that till after I cleaned it all up, of course. You know, Murphy. 1, 2, 3. Hey, look at that, right on the top, and you have to drain the whole thing. I'll put a link in the description for this gear kit. So if you're fixing small animatronic toys or displays, they're probably going to have something similar to this. Like I said, these are pretty standard gears. The armature size varies, and in the kit it has large and small armatures of similar gears, such as these 8-teeth or 8-tooth. But it also has the standard 10-tooth and 14-tooth, which are really common on most animated houses. And I don't remember. The kits aren't very expensive. I got them on Amazon. There you go. And that one turns smoothly as well now. Now, what I am going to do next is I'm going to give these motors a little bit of voltage to see if they spin, but I do not want to send voltage backwards into the circuit board. So how you do that is you disconnect two of the wires, one from each motor. So I'm going to fire up the soldering iron, and we're going to take the two wires and unsolder them or desolder them. Then I'm going to tap to make sure these motors actually spin, in case it's a bad motor as well as just a broken gear. And then if they work, then I'll solder the wires back on, and we will put the axle back in, reassemble the whole thing. Heck, while my soldering iron's heating up, I'll just put the axle in right now, see if I can get the wheels to turn. Now with it out not being in the housing, there's nothing to hold this axle centered. So as it spins, it may actually spin the tires or drive wheels off, because the housing has indentations for these pieces sticking out right here to keep them on centered. So. Now when desoldering a lot of components, you need to get the old solder wet, and the easiest way to do that is solder new solder on top of it. It'll be easier to take the solder off the resistors. This is a much smaller solder blob, and it'll dissipate less heat, or take less heat to break the solder. Now, where do those tweezers go? One wire, and there's the other wire. So the only reason I'm doing this is I want to test these two motors and make sure they actually spin. I'm going to have to elevate them so they don't drive these wheels. Well, you know what, I'll just take the wheels off. I'm going to put the actual wheels under it so it elevates it off my bench and I don't end up just grinding the gears into the mat. Turn on the power supply. And we're going to start with a really low voltage. I'm just going to start it at about 3. So. Wire I desoldered is because it's so old, it's going back to its original position. I don't want it touching anything. There we go. Alright. So I'm going to assume the casing is ground since they have all this stuff soldered to ground, or to one central point, and that the resistor is hot. And that side spins perfectly. And let's try the other one. If I can get this other one, I'll try and lift it because it's on the outside so y'all can see it, and or I'll zoom in. Yeah, it works. So you can hear it. I'll try and zoom in. Should be able to see it spin. Put the wind the wheel back up onto its housing. And there you go. And at 3 volts, or yeah, 3 volts is what I'm running it at. It's pulling 600 milliamps, so it's not drawing a lot of power. I'm not sure what these motors run on. There's no voltage or anything listed on the sides of them that I can see. But they could be running off of the 2 C batteries, which would make sense because the C batteries will provide a longer life before the batteries die. The 9 volts probably powering all the circuits in here, the integrated circuits. Most circuits that you can build aftermarket run on 9 volts. That's how they get powered. It's a pretty common voltage for circuitry. So now I'm going to resolder these wires on and then just reassemble it. Turn it back on one more time. I'm not anticipating it to do anything because I don't have the voice controller, but at least this shows you how to take this thing apart, check the gears. Even these nose gears that are completely fine, they're in that kit. Those kits that I mixed together to make this little tub. So, speaking of that, I should probably make sure the lid's on so in case it falls, I don't lose all my gears. There's one. And there's 2. And I'll also put a link in the description not only to the gears, but to the soldering station that I use that has the voltage power supply in it, the DC voltage supply, as well as a basic one that if you're just learning how to solder or you don't want to spend a lot of money, because the one I use is slightly more expensive, you can get a basic soldering iron kit with a soldering pen. Just plugs into a wall socket for a lot less money. You can use soldering irons for multiple things besides soldering wires. You can actually use them for making holes in plastic, which I hate doing because it does shorten the lifespan of the tip, but it's very common. And it works really good. You need to bore a hole in a piece of plastic. It's also very smelly and can cause cancer. You know, all the Prop 65 warnings if you live in California. Everything causes cancer. Then you can get different tips for it. You can actually burn wood. I actually have a wood burning pen and a soldering pen, and I find the soldering pen works better for burning wood than the wood burning pen does. And it was just a cheap one, and I use that and actually keep it out in my outside storage because I'll use it for soldering on cars as well as I'll use it for soldering or wood burning. Now, most little electronic stuff, they tell you never to drive the wheels because you can drive it backwards on the motor. This one is not going to do any damage to anything. The way they have it set up is if you spun the wheels, the way it's designed with the transmission, since it doesn't have any worm gears or anything, it's not going to do much damage to the motor. It's a little hard to turn because you are driving it backwards, but it's relatively okay. I still don't recommend it, but it has a little bit more forgivability than it does if it was a different type of toy I don't even know who built Robocom. I just know there was a couple of them made, a few different styles. And this is the one that is voice recognition. It's actually pretty neat. I'm sure somebody out there who's more advanced than I am could probably make an Arduino that fits inside that makes this more compatible with modern technology, such as smartphones. I have Arduino stuff, but I'm not very good with it, so it's not something I would do. The one screw that's stuck in the plastic is getting caught on. So let's put his head back together, and then get his back on. Let's not forget about his arms. Go. Now we just got to put all 10 screws back in, 4 on the bottom, 6 on the back. Because of the age of this thing, you definitely don't want to over torque these, so just go to where they're snug and not super torque them. And then the antenna has a small groove. Just make sure it's lined up in that groove. So that way it moves freely and gets caught in everything and smacks you in the face. Okay, so all the back screws are in. Now let's get the last of the bottom screws in. And one. There we go. It's hard to get them centered. These holes are so deep. It's hard to get them down right smack dab in the center to catch the hole. That one was easy. There we go. My screwdriver back. So we got the light on the top again and the light on the front. And that's it, since there's no controller. So this has been the Robocom voice recognition robot from 1984. So this thing is pushing 40 years old, and this is how you take it apart. Wrong way. Always do that. So here's the inside. Here's his light. You know what? I'll just turn off the. So there's his red light. There's his red light in the belly. And this, there's a little notch for his antenna, which I'm wondering if they had another one in the different, because there's a little notch right there. That could be for another antenna or a small wire maybe for a different model option. There's a close-up of the screw holes and the screw holes, and now I'm just going to take my batteries out of it, clean it up, and let them know that it's rebuilt. There's that flat spot. Yeah, really not an easy way to fix that vulcanized rubber, unfortunately. I can try and heat it up with water and try and see if I can get the shape back. But that's the Robocom from, and I'm probably going to chop it up, but it looks like it's Ilsung, Korea. Right there. Guess I'll do it that way so you can actually read it correctly. And copyright 1984, Robocom Inc., all rights reserved. And then it says this device complies with FCC rules, blah, 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 right there. The same legal jargon is put on anything that is radio controlled, hence the antenna. So, thanks for watching how to disassemble and diagnose a 38-year-old toy to possibly try and fix it. So the owner will hopefully find the voice recognition piece. I can get it back to them and let them know the reason it just spun in one spot and flattened out this one wheel, this one, is because it probably, that one gear that was split on the other side was probably still good at the time, and it just sat there and did this, which will damage that wheel. So, thanks for watching. Till the next disassembly video, have a good one.